So, welcome everybody to this week's problem set, which will cover the mock exam for this course. So, the mock exam of this semester is actually the exam that we had last year in the summer term 2020. And yeah, it should give you some idea on how the exam this year could look like. Obviously, the exercises will not be exactly the same, but it should give you some idea about it. So, let's start. Consider a monopolist that produces one good. The total cost of production is given by 20 plus Q by the power of 2, where Q denotes the quantity. Demand for this good is given by Q equal to 100 minus P, where P denotes the price charged by the monopolist. Question number A. What price will the monopolist charge? What profits will the monopolist earn? What will consumer surplus be? So, yeah, the solutions here are pre-written because I already recorded the videos for this mock exam last week, but somehow I had technical difficulties, and then I was not able to upload the videos because I don't know, there were some issues. So I will just voice over the solutions this time and always point with like red color what I'm talking about. So basically, the first thing that we need is we need to determine the revenue of the firm. And in order to determine the revenue, we need the inverse demand function. So what you see here is the demand function, and the inverse demand function is basically not the quantity as a function of the price, but the price as a function of the quantity. So we simply solve the demand function for the price, and that's how we get the inverse demand function. Because then if we have the demand function, we can derive the revenue. And the revenue is simply the price times the quantity. And now, since we have the inverse demand, which says that the price is a function of quantity, we have the revenue solely as a function of quantity. Having the revenue, what we can calculate is the marginal revenue, and this is simply the derivative of the revenue function with respect to the quantity. And if we now have the marginal revenue function, what we can determine is the optimal quantity or the profit maximizing quantity of the monopolist, because the condition which determines this quantity is given by the marginal costs being equal to the marginal revenues. So in particular, the marginal costs are simply Q times Q, because the cost function is Q by the power of 2, 20 plus Q by the power of 2, obviously. So 20 is the fixed cost, and this doesn't matter for the marginal costs, and Q by the power of 2. So taking the derivative of this gives us 2Q, and 2Q should be equal to 100 minus 2Q. Solving this yields the optimal quantity, which is then Q star equal to 25. And this is the profit maximizing quantity for the monopolist. Now, given this quantity, what we can calculate is the price, the optimal price, which is then simply given by plugging in the optimal quantity into the inverse demand function, and what we then get is 75. Yeah, so this is then the profit maximizing price of the monopolist. Given the profit maximizing price in quantity, what we can calculate is the profit. So we simply substitute for all the variables in the profit function. So we substitute those values with the optimal values. And what you then get is 1,230. Yeah, so this is the profit, the maximal profit that the monopolist can achieve in this market. Finally, what we need to calculate is the consumer surplus. And the consumer surplus is basically aggregating the monetary savings that all consumers who are purchasing the product of the monopolist achieve because they have a higher valuation than the price of the monopolist. So the first thing that we need is the so-called choke price, so the price above which there is no demand anymore, and here it's equal to 100. So if the price is 100, it means that no consumer will buy the product, so there is no demand. From this, we subtract the equilibrium price of the monopolist, which is 75, divide this by 2, because if you remember the graphical interpretation of the consumer rent, it was in triangular area below the inverse demand function. So we divide by 2 then, and we multiply it by 25, which is then the quantity which is traded in equilibrium. And this gives us 312.5, which is then the consumer rent. Good. This brings us to B. Suppose that a tax of 20 euro per unit is imposed on the consumers of the good. How will the monopolist's price, monopolist profit, and consumer surplus change after introduction of this tax? So again, we start by deriving the revenue function. So again, what we have at the top is the demand function, but now keep in mind that for every price that is determined in this market, consumers have to pay 20 additional monetary units, because obviously there is a tax here, as was said in the exercise description. So the new demand function will be AT minus P. Yeah? From this, we can then simply derive the inverse demand function, which is then AT minus Q. Then the steps are straightforward, because we already did it in sub exercise A. So the revenue is then price times quantity. So it's then ATQ minus Q by the power of 2. Taking the derivative of this expression gives us AT minus 2 times Q. And then again, if we are trying to derive the optimum, we simply set marginal costs equal to marginal revenue, and this gives us an optimal quantity of 20. Yes, so you can see already there is a decrease in quantity, the reason being that demand is decreasing due to the tax increase. So having derived this quantity in optimum, we plug it into the inverse demand function, and it gives us an equilibrium price of 60. So this is the profit maximizing price for the monopolist. And then we calculate the profit by substituting for the corresponding variables in the profit function. So we end up with a profit of 780, which is also lower than what we had before. The consumer rent is then, so here you have to be careful, because for the consumer rent you have to consider that you not only, so the consumers not only pay the price, which is determined in equilibrium here, but also the tax. So you take the choke price of 100 and you subtract from this the price in addition to the tax that consumers have to pay. Then you multiply this with 20, which is the quantity which is traded here in equilibrium, and divide it by 2 and end up with 200. So as you can see, both profit and consumer rent decreased due to the introduction of the tax, which was imposing 20 monetary units to be paid by the consumers. Question number C is, what is the debt weight loss of this tax? So in order to answer this question, what we need to derive is the total welfare of this economy with the tax and without the tax. So we start with the no tax environment. So here the total welfare is simply the consumer rent plus the profit of the monopolist. Yeah, so that's everything which is included in this economy there. So in total, we have 1,542.5 monetary units as total welfare. Then in the tax environment, we basically have the consumer rent plus the monopolist's profit, and this is 980. But here we have to be careful because we also need to add the tax revenue to the total welfare. So the tax revenue is the tax which is imposed by the government times the quantity which is traded. So it's 20 times 20. Therefore, the tax revenue is 400. So if you then add this to what we calculated here, you actually get the real total welfare because depending on how the government is redistributing or investing the tax revenue, this kind of gets back into the economy, so into the real economy. And then what we can do is we can calculate the debt weight loss in the following way. So we simply take the debt weight loss without tax and subtract from this the sum of consumer rent and profit with tax and tax revenue. And then we get 162.5, which is then the debt weight loss due to this tax. Yeah. So as you can see, the tax is creating distortions, which ultimately end up in a debt weight loss in this economy. The reason being that when there is a tax imposed on the consumers, so actually it doesn't matter whether it's imposed on the consumers or on the firms, at least for the debt weight loss. So what will happen here is that um, so okay, no, that's not really true. It depends on the elasticities. So who's carrying the burden? But I think in total it doesn't matter. So why do we have a debt weight loss? Well, the reason is because whenever there is a consumer who has a higher willingness to pay for a product than a firm has marginal costs or costs to produce the product, it makes sense to trade because there is some gain happening due to this trade. Yeah, so there is a kind of a there is a scope of both of them benefiting by this trade. And if you impose a tax of 20 units on the consumer side, it means that trade does not happen because some of the consumers who had a higher willingness to pay than the cost of producing the product now have a willingness to pay which is lower because they also have to pay 20 monetary units of tax. Yeah, so this is the reason why you have this dead weight loss. So the trade is not happening even though trade would be efficient. The reason being that there is a tax of 20 units to be paid by the consumers. Yeah, so this is the reason for the dead weight loss here. So, okay, question number 2. Consider an economy with two goods X and Y. The demand for good X is Qx equal to 100 minus Px, and the supply for good X is Qx equal to Px. The demand for good Y is Qy equal to 300 minus Py, and the supply for good Y is Qy equal to Py. Both goods are currently untaxed, but the government needs to raise 500 euros of revenue by taxing these goods. Denote by Tx a tax on good X and by Ty a tax on good Y. Answer the following questions. 2a. Calculate the equilibrium price and quantity of good X as a function of Tx. Find the corresponding deadweight loss of tax Tx. Find the revenue from taxing good X. Yeah, so this exercise here is similar to the type of exercise that we have already dealt with 2 times, I think. So we had an exercise sheet where we kind of dealt with a question like this. And we had, I think, one exercise like this in the recap sessions that I uploaded. Good, so let's start. The first thing that we need to determine is the equilibrium price. So keep in mind that since we have a tax, the demand function here changes a little bit. So it's not 100 minus px, but it's 100 minus px plus tx. So you have to account for the taxes, obviously. And we set this equal to the supply function. Solving this will give us px star being equal to 50 minus tx divided by 2. And this is the equilibrium price for this good. Given this equilibrium price, what we can calculate is the equilibrium quantity, and this we can get by simply plugging in the equilibrium price into either the supply or demand function, and it will give us an equilibrium quantity of 50 minus tx divided by 2. Now, given the equilibrium quantity, what we can calculate is the deadweight loss, because as you remember, maybe we had a formula for the deadweight loss, so how to calculate the deadweight loss kind of in a fast way. So it was given by 1/2 multiplied with the change in quantity due to the tax, which is here, so in absolute terms, which is here tx divided by 2. Yeah, so if there is a tax of 0, there is no change of quantity. If you take the no tax environment as a benchmark, as soon as the tax is strictly positive, what you will see is that there is a change in the quantity which is traded in this economy. So it's tx divided by 2 here, and this will be multiplied by the tax again. What we end up with is a deadweight loss of 1/4 times tx by the power of 2. And since we will need it later, we can derive it already here, even though it was not part of the question. So the marginal deadweight loss is then simply the derivative of the deadweight loss with respect to the tax, and it's equal to 1/2 times tx. The tax revenue on the other side is then simply given by multiplying the quantity which is traded in this economy with, or at least for this product, with the tax in this for this product, and this is then simply 50 times tx minus tx by the power of 2 divided by 2. Again, since we need the marginal tax revenue for this exercise, we simply take the derivative of the tax revenue with respect to the tax, and we end up with a marginal tax revenue of 50 minus tx. And this finishes this sub-exercise. Now, in sub-exercise B, we are asked to do the same thing with good y. So we are asked to calculate the equilibrium price and quantity of good y as a function of ty. And again, we are asked to find the corresponding deadweight loss of a tax ty and to find the tax revenue from taxing good y. So again, let's start with finding out the equilibrium price. So here, again, we account for the fact that now the demand function changes a little bit because we assumed that there is a tax in this economy. So the demand function is 300 minus py plus ty. So in parentheses, obviously. And this should be equal to the supply, which is then simply py. Solving this will give us 150 minus ty divided by 2. And this is the equilibrium price. Then plugging this into the here, I think I plugged into the supply function, yes, gives us the equilibrium quantity, which is then also 150 minus ty divided by 2. Using this, we can calculate the deadweight loss, which is then 1/2 times the tax times the quantity change due to the tax, which is here as well ty divided by 2. So for product X, it was tx divided by 2. Here it's basically the same because, yeah, as you can see, the change in quantity when we are increasing the taxes is the same for both products. So the total deadweight loss will then be 1/4 times ty by the power of 2, and the deadweight loss, the marginal deadweight loss, will be simply 1/2 times ty. Now the tax revenue is 150 times ty minus ty by the power of 2 divided by 2. So here we simply multiply the equilibrium quantity here with the tax, and then we can calculate the marginal tax revenue, which is simply 150 minus ty. And yes, this finishes this sub exercise, and then we come to the condition which determines the optimal taxes for good X and Y, so the optimal commodity taxes. So we are asked the following: write down the condition for optimal taxes as a function of tx and ty. So in particular, write down the Ramsey rule for this economy. So if you remember, the rule was that the commodity taxes should be set in a way that the marginal debt weight loss of a good divided by the marginal tax revenue of the good should be equal to the marginal debt weight loss of the other good divided by the marginal tax revenue of the other good. Yeah. So by following this rule, you are making sure that you minimize the distortions in this economy for a fixed amount of revenue that you want to raise. Yeah. Any other um, any other taxes or tax level that you're setting, which is not covered here by this condition, would lead to more distortions, so to less welfare for reaching the same tax revenue. So then if we plug in for the corresponding values, so we plug in for the debt weight loss of the marginal debt weight loss of good X, which we calculated before, and the marginal tax revenue for good X, and the same thing for good Y, we end up with this condition here. Yeah? So this is then characterizing the optimal ratio of the taxes in this economy such that the distortions are minimized. Then sub-exercise D, find the total tax revenue as a function of Tx and Ty. Explain how you can calculate optimal taxes, Tx and Ty. Hint, write down the system of two equations with two unknowns, Tx and Ty, which characterize the optimal taxes in this economy. So here, the two equations that we need to consider. So the first one is the one which we saw in the previous sub exercise. So the first equation here is determining the optimal ratio of the taxes in this economy. So it's saying so given that we have a particular value for one of the taxes, what should be the value of the other tax? So this is giving us the optimal ratio. And then the second condition is telling us how much we should actually tax in order to raise a particular amount of tax revenue. Yeah, so these two equations, so now if we plug in for the corresponding values here and here, we end up with this equation here. So this is also an equation, so one equation which depends on Tx and Ty. So what we have is a system of two equations. The first one here determining the ratio, and the second one here determining the taxes in absolute values to raise a particular amount of tax revenue. Yeah, and by solving these two systems of equations for Tx and Ty, we can calculate the exact values of Tx and Ty, such that the distortions are minimized and we raise a tax revenue of 500. Yeah, so how you would proceed here. So basically, if you look at the exercise description, here in the exam, it did not ask you to actually calculate it, but here the question was explain how you can calculate it. Yeah, so it was sufficient to write down the two equations here, and then to say that you would solve it for Tx and Ty without actually solving it. And yes, this finishes this exercise.